my screen. So can you see my screen right now?
Yes, we can see it.
Perfect. So before we start, I will say a few words about myself. I'm an embedded software engineer. I've worked for projects in critical systems, in aeronautics, onboard software, for satellites, terrain, etc. And I have experience in documenting, implementing, and testing embedded software solutions. So in this picture, I've added some industries in which I've worked. So aerospace and defense, industrial and energy, rail, and I will have a project in medical critical software. So the contents of this presentation will be embedded system introduction. We'll discuss about testing embedded systems, about simulators for microcontrollers and real-time operating systems. I will say a few words about industry standards. We will do an analysis of Arduino functions, and I will recommend some development kits for beginners and advanced users. So let's start. What is actually an embedded system? According to Wikipedia, an embedded system is a controller with a dedicated function within the larger mechanical or electrical system, often with real-time computing constraints. If you ask me, definition for an embedded system is a controller that has at least a microcontroller or a microprocessor, which was developed to has a certain function, and in general, that function will have real-time computing constraints. And you will find embedded systems in almost any device, in smartphones, in cameras, in aeronautics, in the printers, in cars, etc. Differences between a microprocessor and a microcontroller. Often people are confusing these types of processors. So the main difference between them we'll discuss now. In this picture, I don't know, I hope it's big enough. You will see a block diagram of Admega 328P, which I think is present in Arduino Uno. So as you can see in this block diagram, the CPU, the SRAM, the flash memory, and also some data buses and some timers are present inside the microcontroller. While in a typical microprocessor system, the CPU it's outside, and you have the ROM and RAM memory, the inputs, outputs, and other peripherals outside the CPU. Application of embedded systems. You will find, as I said before, embedded system in consumer appliances like entertainment, heating and cooling, personal devices, in healthcare and wearables like fitness and health tracking, medical devices, in factories and industrial automation, program and logic control, process control, in smart buildings, in smart cities, also in satellites, in aeronautics, in helicopters, you name it. Testing embedded systems. What is testing? Testing is an organized process in which the behavior, performance, and reliability of a system is verified against the design specifications. So any embedded system that is created, it has some documents which are named specifications. These documents contain hardware specification, software design specifications, testing specification could be. So all the tests should be correctly documented, and any error or mismatch between expected behavior and actual behavior should be flagged in an issue tracker. If the error is a pretty large bug or it's a critical bug, it could escalate to a documentation update or to a specification update. Software testing. I've listed here only 3 types of software testing. There are more, but these are the main that are used. So it's software unit testing, also called SUT, software integration testing, SIT, and software validation testing, SVT. Software unit testing, the unit that has been tested could be a function or a class depending on the programming language that is used in the project. The unit is isolated from other units in the project. So if the current unit that is tested is using other functions or methods from another unit, those methods are stopped and the return value could be added by the tester. The test cases are developed by the tester according to the specification, and only black box testing is allowed. Software integration testing, SIT. All the units are integrated together. The model to be tested is represented by a set of functions or classes, as I said before, depending on the programming language. White box testing is allowed at this step, and SIT in general is the responsibility of the developer. But you will find some projects when the SITs are done by the tester. Software validation testing is done at the end of each software integration using partial use case scenarios. White box testing is allowed, and it is in general the responsibility of the developer. Tools used for testing embedded systems. There are many tools used for embedded systems. I've listed a few, and I work with IBM Rational Test Real Time, also known as RTRT or IBM RTRT. It supports both host testing and target testing, and also debug on target and on host. TESI, this is used in general in automotive. LDRA is the software which generates coverage for aeronautics and for critical systems. And some custom tools developed internally, for example, I don't know, a C parser that verifies if the naming convention of a function is okay, or the parameters are declared correctly. Simulators for microcontrollers. Why use simulators for microcontrollers? So a simulator allows the engineer to prototype boards at a much lower cost. Also, it helps testing functionality before ordering thousands of boards. And if you have an MVP, it's much easier to make changes. So the simulator that I used a few years ago is called Proteus Virtual System Modeling, or VSME. It enables rapid prototyping of both hardware and software designs. It can simulate microcontrollers from Atmega, from Atmel, I think for NXP and Freescale also. And besides simulating microcontrollers, it can simulate basic electronic parts, components like resistors, LEDs, diodes. And also you can upload your binary code, your binary software to the device and test your entire program in it. It has also a serial monitor, if I'm not wrong. Real-time operating systems for embedded systems. These operating systems are used in general when real-time tasks are needed. So basically, this in a operating system, the scheduler is created to provide a predictable execution pattern. This is particularly of interest to embedded systems, as these systems, as I said before, often have real-time requirements, and the real-time requirement is one that specifies that the embedded system must respond to a certain event within a strictly defined time. Some examples of real-time operating systems: FreeRTOS. It's free, and I think it's also open source. Supported microcontrollers, the NXP microcontrollers, some Renesas microcontrollers, Atmel, Freescale, which was acquired by NXP, and now the microcontrollers for Freescale are also named as NXP, Microchip, etc. You need to check the official website for an updated list. ECOS, this I'm sure it's open source and free. It supports architectures like ARM, PowerPC, MIPS, and ThreadX, which supports ARM, PowerPC, Renesas ARM Synergy, Texas Instruments ARMS, but this real-time operating system, it comes with a commercial license, and I think they don't have a free version for it. Industry standards. In developing software for critical systems, the developers need to use some standards. These standards are not intended as a software development standards. They are used as an assurance that in the implementation of the project are used a set of tasks to meet the objectives and level of criticality. So for avionics software, it's DO178B or C. In automotive, it's AUTOSAR. For automotive, I think AUTOSAR it also includes a software development standard besides the document standard. And the military standard, it's MIL-CTD 882D. For those who are more interested in these standards, you can search them on Google and you'll find many information on Wikipedia. For analyzing an Arduino function, I've developed a very complex program. It's the Blinky program for the Arduino Uno. So if anyone used Arduino before, you are familiarized with how a program looks in Arduino. So we have the setup function, which runs once and then it stops, and the loop function, which runs over and over again. So the pin mode, you select pin mode, the built-in LED as an output, and you blink an LED using the function digital right. But what happens to the microcontroller when you are doing this? And also how you can do this using only C code. So I've written a simple C program that it does the same as the Arduino Blinky, but this time I've used the registers from the microcontrollers. So these two headers, the input-output header, I've imported because I need two definitions. And the delay header I've imported because I will need this software delay function. So this is called the data direction register for port B. I will explain in the next slides why this value. Now, this port is the register port, which we can select what is the status of a specific pin at a certain moment. So here I'm turning on port PB5 and I'm turning off PB5. If you look in the datasheet, you will find DDRB. This is the datasheet for Atmega 328P, which is used in Arduino Uno. So you'll find data direction register for port B. And as you can see here, it's a read-write register. and I want to put 1 here, so I can inform the microcontroller that I need PB5 as an output. So these are 8 bits. This is the second bit for the second fourth pair. And now you can understand why I put here this value. We have 0, 0, 0, 0, 0, 1, 0, 0, which in hex it's 2, 0. Now the port B is the port B data register, which we can modify the status of a port, of a pin, after we configured here in the data direction register. So it's the same position in the register. This is a 8-bit register. So this is the reason I've added here this value. Now a refactoring for this will look like this. So I'm using an OR gate, and I'm shifting 5 positions to the left. Using this code, I will not affect the other values in the register, because with this, I will say that only pin 5 it's an output, and I put 0 on the others. With this, I put 1 on PB5, and I don't care for the other values. And now, in an infinite loop, I will just do a XOR gate, the same like here. I will shift 1 left for PB5, and I will run this in an infinite loop. Development kits and evaluation boards. Before we can talk about recommendations, I think we have to answer few questions. So what is the purpose of a development kit? How to choose a board as a beginner? How to choose a board or a microcontroller for an advanced project? So what is the purpose of a development kit? You've probably seen all these development kits sold by various companies. In general, companies that are producing microcontrollers, they are creating a development kit for a specific microcontroller. So an engineer that wants to develop a project can buy that development kit, can test his MVP on it, and if the board it's okay for him and for his project, he can buy only the microcontroller and create his own board with a programmer, a debugger, or something like that. So you will see, for example, I think Microchip has some development kits in which the compiler is limited. So you can't create a very big program. They are limited, I think, like 12 or 16 kilobytes. Now that we mentioned this, how to choose a board as a beginner. So the first thing you have to check when you buy your first board as a beginner is a community strong enough around this board? So if you're a beginner and you buy a board that is used in critical industries and you don't find many information about it on the internet, you will get stuck with it because you don't have anyone to ask. You don't have a community or a forum or something like that to ask your problems. So let's say Arduino. Arduino has a very strong community. It's a perfect board for a beginner. The second thing you have to check is the integrated development environment and also the compiler. Are they free or you have to pay a commercial license for it? In general, for almost all development kits, the IDE and the compiler is free. But in some cases, there is a free trial or free version of the compiler, as I said before, and you can't develop very large projects with it. Now, how to choose a board or a microcontroller for an advanced project, or let's say you're an advanced user. Basically, it's the opposite for the beginner. You have to choose a board that is tested in the specific industry you want to realize your project, to implement your project. You have to choose a board that has a commercial compiler or a very good compiler, because in case you have problems with it, you have to have support from the company that made the compiler. You have to check how you will debug your board or your microcontroller. And also how much it will cost the microcontroller, because if you are planning to develop thousands of boards, I think the cost here could be involved. Recommendations for beginners. I will discuss about microbit, which is a very tiny board. Sorry. It's a very tiny board. What is happening? Okay. It was created to introduce children into programming. There are available 3 programming languages for it: JavaScript, C++, and MicroPython. And also it is using an ARM architecture processor. Another recommendation will be Arduino, any model, or if you're a more advanced beginner, you could choose Atmega 328P or Atmega 8 or Atmega 16. These are all, I think, 8-bit microcontrollers. So regarding microbit, it's an ARM Cortex M0. It has a Bluetooth low energy, radio, serial, accelerometer, compass, temperature sensor. Also, as you can see here, it has a tiny display formed by matrices of LEDs, some buttons. And the biggest advantage is that has support for 3 languages: MicroPython, JavaScript, and C++. And also, they are available online and offline integrated development environment. So let's say you are on a laptop that you don't have administrator or root access, and you want to code something for your board, and you can enter online. I think it's embedded.org, and you can code in MicroPython or C++ or even JavaScript online and download your binary project. And also you can, if you have an account on their website, you can share your code between different machines only by logged in and see your project history. And this is all free, and microbit is open source. Now, some recommendation for advanced engineers. I will recommend NXP, formerly known as Freescale, Coriva MPC 55. This is a PowerPC architecture. It's a RISC architecture. This is used in automotive, in avionics, and I think also in onboard software. Renesas SK S7G2. It is also used in automotive. Any ARM-based boards, which is a very interesting architecture. And EasyPick, this is a board for microchip, EasyPick V7 development board. Thank you. Now I will, if I can, see how I...
Do you need help to stop sharing the screen?
No,
here we go.
It's blocking. Okay, so just 1 second.
Yes, absolutely. So if anyone has questions, you can write them in the chat. I see 2 questions already. If anyone else wants to ask something, just write in the chat. So Madalin, the first question. Oh, you want to show that? Go ahead. Yeah.
So this is the microbit. It's more powerful than an Arduino, and I think it's like $18 in my country. I don't know in other countries. So, and also I will want to show you, this is how a professional board looks like. So this is the PIC V7. I don't know if you can see anything, but it has all the ports and peripherals added on the board. Now I do want to show you something else. Do you still hear me?
Yes, we hear you.
Okay, so can you see my whiteboard now, right?
Yes, we can see it.
So why is interesting using more complex microcontrollers is that you can have your drivers, I don't know if you, okay, and your application. And if you need to remove the microcontroller and replace it with another one from another company, you just need to rewrite this part of your application, the drivers part, when you are accessing microcontrollers register, and your app will remain the same. So your algorithm will stay here, and you can replace here your microcontroller and just update the drivers, and your application will work. Perfect. Now let's discuss about the questions.
Yes, so the first question is from Odaria. What is the difference between Atmel, Atmega, Arduino?
Okay, so Atmel is the company that made these processors, these microcontrollers, and Atmega, it's a model of microcontroller from Atmel. So the full name of an Atmega microcontroller is Atmel, Atmega, and the number of the model. So for example, in Arduino Uno, the microcontroller is Atmel, Atmega 328P. I think this cover up.
Yes, so the next one is from Hissen Wen. Will you share your experience with measurement medical signal? How do you handle them? And another question is, how do you decide and tune baud rate and bit rate?
Yes, this is an interesting question. So for now, I don't have any experience with measurement medical signal, but I did study a little bit. Also in how to tune baud rate and bit rate. Basically, if you're using a serial communication and your baud rate is very high, and you still experience bottlenecks in your application, maybe it's a good idea to change your communication protocol. So let's say you have very large amount of information to send, and your baud rate is very high, and you still have bottlenecks. You could choose, I don't know, CAN or Ethernet communication or something like that.
Thank you, Madalin. So the next question is from Temitopi. It's, what does white box, black box testing mean?
Okay. So white box testing means that you test a piece of software without looking in the code. Sorry, with looking in the code for white box testing. So when you're testing white box, you have code and documentation. When you're testing black box, you don't need and you're not allowed to look into the code, only into the specification and create your test scenarios based on your specifications. Because if you look into the code, they'll probably miss something, or you can, and it's a risky thing because you can create your test scenario based on the code, and that is not a good idea.
Yes, thank you. And then we have a question from Venkatesh. Do you think learning embedded Linux is of any help?
Yes. I think learning embedded Linux is the future. Embedded Linux actually is the future, because as you can probably know, the cars and trains and airplanes are evolving very fast, and they need a more faster technology. And also, this embedded Linux could be used in entertainment systems in this industry. So, for example, an entertainment system in a car or in an airplane or in a train, they are using embedded Linux. So, yes, for embedded Linux.
Then we go on to the next question from Shivam. If you wanted to build a computer vision RL-based robot, how would you go about it?
So if I want to build a computer vision based robot, first, I think if I don't have any limitations, I think I can choose a microcontroller that is designed specifically for capturing images and processing them. And I will send, according to the specification, I think I will send all the data to a more powerful computer like a Raspberry Pi or a Jetson Nano, so I can do all the controlling there and the capturing on a microcontroller that is specifically designed to capture images. I think it's okay.
Yes. And the next one is from Venkatesh. Any suggestions of development board in RISC-V architecture?
So RISC, it stands for Reduced Instruction Set Computer or something like that. And basically, almost all microcontrollers are RISC. Microbit is an RISC. The board I've just shown you is an RISC. I think also Arduino is an RISC. So basically, the suggestions I've presented in the slides before covers up this question.
Perfect, thank you. And the next question is from Temitope. Which programming language is mostly used? Is VHDL good for embedded systems?
I didn't use VHDL, and I did had some colleagues who used VHDL, but I have no idea about it. But if you want to learn embedded system, I think you need to learn. So you need to know C and C++. So if you know C and C++, I think you can cover any other boards that are based on MicroPython or JavaScript or any programming languages, even MATLAB Simulink, if anyone used it. In the back is generating C code.
The next question is from Ashish. I'm working on a CamBot in which I want to rotate my camera exactly in the direction in which the human is moving. I'm kind of worried about my architecture. What kind of architecture do you prefer? And is there something better than servo motors to have variable and controlled rotation?
Yes, I think I have a better solution for this. So what I understand here is that you are using or you are trying to use servo motors to control the rotation, but keep in mind that servo motors have a little bit delay, they have some noise, and also they're not very precise. So what I will recommend you to use, it's a brushless motor. The motors that are used in the smartphone gimbals or in the drones or in the DSLR gimbals, you know, that kind of motors that have no brush, and it is very precise and very silent, but it is a little bit more difficult to control that motor.
The next question is from Matthäus. Is assembler still used?
Is not used as a programming language. So I don't know anyone right now that programs in assembly language, but we did find like few years ago a bug in the compiler, and to identify the bug and to correct it, we had to study a little bit of assembly language because that was what we have at the moment. Ashish, brushless motor. So without brushless.
Let me see. So the next one is from Jess. Would you recommend Raspberry Pi 4 or Jetson Nano for computer vision applications? What about for building a small car or robot controlled by reinforcement learning?
This is a very, very good question, because I just ordered a Raspberry Pi 4 and the Jetson Nano, and they're arriving by the end of this week, because I don't know what to answer for these questions. And this is the reason for why I've ordered these two boards. So I think, I don't know, they have advantages and disadvantages. I don't know what to say about this. I haven't studied neither of them, but I can tell you next week honest opinion.
So Madalin, when you have tried them out, you can get back to us and give us introduction, or just tell us more about it. That would be great. And the next question is from Dimitro. Do you have an experience with microcontrollers for wireless communication?
Nope, I don't have any experience with microcontrollers for wireless communications. Sorry.
So that was about it. And Jess also said it would be great to know your experience. So let's, one more question here from Shivam. Which microcontroller should we use for controlling or using ML on inputs from FMCW radars?
So I think FMCW are continuous radars. Can you confirm? Okay, so which microcontroller should we use for controlling or using machine learning on inputs from? I don't know. I think you can use a Linux embedded for this. I don't think a microcontroller it's a good. I don't think a microcontroller is a good solution for it. I'm not sure, but I don't think it's a good solution to use a microcontroller for this.
And he said also it's frequency modulated continuous wave radar. So that was the FMCW.
I've read something about them, but I don't have any experience with this.
Are there any other questions? Please ask them now. Temitopi is asking which motor will be good for a mobile robot.
Mobile robot. So you are referring that it has some kind of wheels, or you are asking about the motor that which to control the arm or the leg, or you are referring a robot as an humanoid robot or as robot in general?
Wheels.
Wheels. Okay. So for wheels, you have to use brushed motors. So for precision and for silency, for no noise, you can use brushless, but they are power consuming and your battery will drain faster. But for wheels, you can use almost any brushed motor. Keep in mind that I've noticed someone who used the step motor for wheels, and that is not a good idea.
Thank you, Madalin. So any other questions now? Humanoid as well. She's asking for the humanoid.
For the humanoid, and to control like the arms or the legs, or also with wheels.
Temitobi, can you write specify it? Legs and arms.
For legs and arms, if you want, let's say, a cheaper solution but a fully functional solution, would be almost any servo motor, but you have to look in the datasheet for the torque. I think you can find and see if your servo motor is powerful enough to move your legs on or your arms. But if you need a precise movement for legs and arms, you can use brushless motors. You can search on Google for brushless motors and you will see various applications, very interesting with them. So the brushless motors are the motors used in drones and quadcopters.
Any other questions? You get a lot of thanks and awesome at least, so that's good. Thumbs up for that. And we're going to wrap it up now. If you don't have any other questions. Oh, what do I use to lift a robot is Temitopi's question now.
To lift, we are talking about the same humanoid robot, right? So it's sitting or something like that. Static motion. So you are in a position and you're trying to lift the robot like of movement and not flying, right? Okay. So it's essentially to have an accelerometer, a compass, and I'm missing the term now, but I think an accelerometer and a compass will work. You need to get the accelerometer vector at each time, so you can see how your robot acts and what is his actual position. So you're going to need a feedback from an accelerometer, and I think you will need like more of them, because you have to know how the leg is oriented considering his body, and how his arms are oriented considering his body. So if you use accelerometer and a compass, you can have all these accelerometer vectors in 3D space, and I think you can do some algorithm there to basically to move the robot.
The next question is what from Udaria. What do I use for pressure detection?
A barometer sensor, barometer sensor for air pressure. I think it's about.
The question for Badresh is what kind of microcontrollers can we use in hydraulic or pneumatic applications?
Pneumatic application. I don't have the experience in hydraulic or pneumatic application, but depends on the hardware specification. If you're not blocked by some communication protocol, I think you can use almost any microcontroller.
Vipul is asking, how can we use embedded systems for face detection or image detection to stop crimes?
For this, I think it's a better solution to use embedded Linux and not a microcontroller or an embedded system using a microcontroller. And I think for this, we have to have many cameras in cities on the streets, and probably to do real-time scanning for the faces. But it is a difficult task, and what we've seen in the movies, I think it's going to pass a time before we can have it.
Thank you, Madalin. So next question is from Venkatesh. Have you worked with MicroPython? How fast or how slow is it?
So it's not very fast, but it's not slow either. One disadvantage of working with MicroPython, for example, with working with MicroPython or microbit, is that you can't use Bluetooth and MicroPython at the same time, because the MicroPython stack use, I think, 10 or 20 kilobytes of memory, and also the Bluetooth Low Energy stack needs about 6 or 8 kilobytes of memory, and the microbit has only 16. So if you want to use MicroPython, let's say on microbit, you have to deal with the fact that you can't use Bluetooth. But MicroPython, it's very good for prototyping rapidly project that you're working on.
Udaria is writing again, not air pressure. I'm asking about a place that has been affected by earthquake, and I'm building a device to check which parts are prone to collapse afterwards.
This is a difficult one. So what you're basically saying is that you have some parts that are standing one over another, and you have to detect which part it's going to collapse first, right?
Yes, this is what he means.
I think it's very difficult to do this. Honestly, I don't know how to do it. So if you have a pattern, let's say you do know that you have a roof and you can measure something of force that the roof is applying on your house or something like that, I think that can be done. But if all of them, it's like every stuff over and over on other stuff, I think it's almost impossible to do it.
The next question is from Sushil. Which camera do you suggest for near real-time posture detection project? Have you worked with Kinect sensor camera? If yes, how is the performance?
I didn't work with Kinect sensor camera, but I did have a colleague at work who worked with this. and he was very enthusiastic about it. He said it's very interesting. Maybe I can ask him and provide you with a feedback from him, because I don't know how can I answer this question. Just to remember me on Slack.
The next question is, what was your biggest challenge during your work as an embedded engineer, and how did you solve it?
So the biggest challenge, I think, is not the technical part, in which you can improve. So you can improve your technical part or your technical knowledge. But I think the biggest challenge is to work very careful and to avoid creating bugs and very, very critical problems in the code and in the test that you are making. So when you're creating a test for an embedded system, you're creating it, you've obtained your results, and after you comes another person which reviews your tests and makes comments about your test, and you have to review again your test, and so on and so forth. So I think this is the biggest challenge, to be always patient and always very I don't know how to say it, or very conscient about what you're doing.
The next question is from Surav. Pro tips for getting started.
For getting started in developing embedded software. Okay. The biggest tip of the day, just do it. Buy a board you think you can manage. So don't, I think on the previous webinar, someone said, don't, I don't know how it was, don't start from the top or something like that. So find a smaller board, find interesting projects, and also it's very important that you learn how to read a datasheet for a microcontroller. So for now, let's say you're using Arduino, you have all the functions created for you. They are there. If not, there are some other libraries that you can add to your project. But in the future, if you want to build a career into embedded systems, you have to learn how to read a datasheet and how to find your registers and how to find your timers and how to set your timers and how to understand why your project is not working because you're on a wrong data bus or something like that.
Thank you, Madalin. So I have another question regarding that. If you are a beginner, would you say that you should buy a Arduino or microbit? What would be the preferred or better choice in that sense?
I think a microbit. It's a better idea to buy. From what I know, if let's say you have some shields or sensor from Arduino, if you had an Arduino board, there are some adapters to add to the microbit so you can communicate with an Arduino shield. But I think it's best to use microbit because you have more possibilities. You have a more powerful microcontroller. It's an ARM Cortex, and also you have you can learn other programming languages like MicroPython or JavaScript. Starting from the idea that you already know C or C++.
Thank you. And do you have any suggestions if you want to combine AI or deep learning with a microcontroller? Which one would you use in that case, both as a beginner or more advanced, if you can have two different suggestions?
So if you want to combine artificial intelligence with a microcontroller, I just read a paper today about that. So it's actually a very difficult task because in the industry right now they're used some old architecture boards or old architecture microcontrollers, because basically what the company does has a software developed and they start from that and developed on top of them. And right now there are some solutions for developing artificial intelligence using microcontrollers. So you can use, I think, I don't know if I've shown to you, but this is the Renesas Synergy. And I'm working with this board right now exactly for this. So right now I'm trying to collect data from different sensors and see how can I implement a model into it. I'm not sure if you can do it with smaller boards like a microbit or like Arduino. I never tested. I'm not sure how the performance is, but basically this is a advanced task. So for an advanced task, you will need an advanced microcontroller. And if you want to use an advanced microcontroller, I think you need to have some intermediate knowledge about microcontrollers.
So maybe it's better to just start out by using microbit and Arduino, and then you can build your way up, as you said before. And this quote was from Temitopi's webinar,
Yes.
which said you can't start from the top of the mountain. And that's such a good
Exactly
saying, because it's so true that you have to start with just getting familiar with the microcontrollers and learn how they function and integrate them with the programming, I guess, and then you can go from there.
Yes. So don't start building a rocket before you know how a rocket works.
Yes, exactly. And we have two more questions. I think Temitop is asking, must I be good in mathematics for this career?
I don't know. You don't need to be very good at mathematics, but it could be useful. It also you have to know some basic bitewise operations and some bit knowledge, and also I don't know how it's English it's called, but something like PC architecture or microprocessor architecture, to know about registers and stacks and memories, etc.
We have a question from Ingus as well. What could be the biggest innovation changes for embedded systems field in the near future?
So what is Renesas trying to do right now is to have integrated in your IDE code generator for your drivers. So this board has this right now. So I think this is innovation, because from what I know, the drivers generated for this board are certified and they can be used in many applications. So what I see an innovation here for this board is that you start your IDE, you're configuring your microcontroller with a few clicks, and without opening like for reading 2 or 3 pages from a datasheet. It's good and wrong at the same time, because it's good that you can start very fast in developing for this board, but it's also not a good idea because you will forget how to read your documentation for your microcontroller. Another innovation, what I see with this microcontroller, is that it can run a real-time operating system, and you can configure it to run very, very fast. for certain tasks.
Thank you, Madalin. So anyone else have any questions? Otherwise, we have tried to record this webinar, and I will stop the recording now so we can do a group picture and thank Madalin as well